Okay, this is for my AP chemistry classes. I'm going to try to explain acids and bases, at least the definitions in the first part and the notes. You should be able to find these notes on Google Classroom, and I can also send them out in an email, so if you need them, let me know. So there's different definitions of acids and bases, and you need to know them for the AP exam. Some of them are really easy, some of them have a little bit more explaining, but you should be able to catch on pretty easily. The first one I'm going to talk about is Arrhenius's definition of an acid and a base. It says that an acid donates a hydrogen ion in water. So you should have your strong acids and bases memorized. If you don't, you can work on that. So hydrochloric acid is a strong acid. And that by definition, it's saying that it donates a hydrogen ion in water. When I dissolve this into water, ionization rules, it says that this is going to split apart into a hydrogen ion and a chlorine ion. And so in this case, we have a hydrogen ion present in water. So that's the definition of an acid for Arrhenius. Same thing goes for bases. So if you have a strong base like sodium hydroxide, the definition says that it donates a hydroxide ion in water. So this one would break apart into sodium ions and hydrogen ions in water. So then we would have our hydrogen ions in there. So acid and a base. So this fits a lot of definition, or this fits and it describes a lot of acids and bases, but it doesn't cover everything. For instance, it does not cover ammonia, which is a really big problem because it is slightly basic, well, depending on the solution, but it doesn't cover ammonia because ammonia doesn't have those parts. It limits only the chemicals that have either a hydrogen or a hydroxide ion to be acidic or basic, and not everything has those. So we have Bronsted-Lowry definition, which is slightly different and a little bit better. The definition is that an acid is somebody who donates a proton, which might seem a little confusing, very similar to the previous definition. If you're donating a proton, what it's talking about is a hydrogen ion again. But if you think about the hydrogen atom, it would be one proton with one electron orbiting around. When it becomes an ion, you are losing that electron, and so then you just have the proton floating around. So it's still talking about a hydrogen ion, it's just doesn't have the electron with it anymore, so now it's just a proton floating around. So the acid definition is donates a proton in water, and the base is accepts a proton in water. So we're looking for the transfer of this hydrogen, who's accepting and who's donating. This is a better definition because it helps to explain ammonia. So ammonia is NH3. So it can accept a hydrogen and become ammonium. So by this definition, it would be a base, which we'll work problems with that, and I'll actually write out the balanced equation. I don't have a whole lot of boardroom to explain that. This is going to be the main theory that's used for AP chemistry. So this is the main definition we're going to be looking at and focusing most of our notes on. And then we have the Lewis definition of acids and bases. And so the Lewis definition says accepts an electron pair for the acid and donates an electron pair. So if you think about those transfer of electrons in your Lewis dot diagrams, where are they being transferred to or from? This is going to explain all traditional acids and bases, plus a host of other compounds. So that is probably the best definition, but we stick with Bronsted-Lowry because that's what the AP exam mostly looks at. So moving on in the notes, I just covered the first part, the top. So Arrhenius, Bronsted-Lowry, and Lewis definitions. These are the NIMSY notes, which you can also Google online. The Bronsted-Lowry concept of acids and bases, they have what's called a conjugate acid and a conjugate base, which is a pair. So if you have your acid on one side, it's going to be the conjugate base on the other. And if you have your base, it's going to be the conjugate acid on the other side because it has been changed. So once ammonia accepts a hydrogen and becomes ammonium, now this is an acid because now it has a hydrogen, it has a proton to give. Does that make sense? I don't know. I don't have any feedback because it's a video. So we'll work, there's examples in your notes and we'll talk about them. So when you're looking at the examples in your notes, it says acid base, and then it says Ca, which stands for conjugate acid, and Cb, which stands for conjugate base. That's a 5-minute video. I think that's enough to kind of chunk and chew for now. That works you through most of the first page of your notes, and we'll kind of go from there.